All right, vegetarians, let's get to the beefiness. So we're dividing here. There's a fraction, right? And you have an imaginary number in the denominator. So we showed you what complex conjugates are. We even showed you a trick on how to work with complex conjugates, which will help us cut these problems down by half. And so we're going to go ahead and apply this idea of the complex conjugate. Here's what we do. We don't want this I in the denominator anymore. So we're going to multiply it by the conjugate, because we know if we multiply by the complex conjugate, it's going to just become a regular number. The i's will disappear. I just can't do that to the bottom, though. I got to do it to the top as well. If we multiply the top, we distribute, right? The 2 times the 3 is a 6. And then this 2 times a minus 2i is a minus 4i. That's an I. The bottom is a complex conjugate. What's our trick for this? Well, 3 times 3 is 9. 2 times 2 is 4. And if you missed that memo, go back to the previous video. 9 plus 4 is 13. Please don't subtract 6 minus 4. You can't, because there's an I attached to the 4. And I is the square root of negative 1. It's an imaginary number. Now, this is pretty much it. We could be done at this point. This could be it. As a formality, sometimes we split it up. So we split the fraction up, right? It's 6 minus 4i. And they both get the 13. So this gets a 13 on the bottom. This gets a 13 on the bottom. So as a formality, sometimes we actually write the answer like this, with one fraction by itself, an operator sign in between, and then the other fraction with the I in front. This should be reminiscent of the standard form of a complex number as a plus bi. So you could say, hey, a is this, and b is this, with the I at the end. Part B, remember the little subtle things, right? I mean, there's a 1 right here in front, if that helps. Okay, so let's go ahead and multiply by the conjugate. This is 5 opposite sign plus 1i. 5 plus 1i. And if I distribute the top, that's a 20i. And then this is a plus 4i squared. Because I have an I and an I times I, right? That's I to the 1 times I to the 1. We add the powers. 1 plus 1 is 2. For the denominator, right, we're distributing this. You could do it the old-fashioned way, or we could just do the little trick where it's going to be 5 squared is 25. And then 1 squared is 1. We get 20i plus 4i squared over 26. Interesting. But Mr. Over, what is I squared? I'm glad you asked that question, Mr. Over. It's negative 1. So we end up getting a negative 4 plus 20i over 26. Let's separate this. And we have some work cut out for us, because we're not done. We have to reduce. Okay, I never taught you how to reduce. Oh, I'm sorry, you're right, because that was back in the day. Technically 6th grade, but it's okay. So let's kind of remind you how to reduce. What's the biggest number that goes into both of these two numbers in this first fraction? A 2. And the second fraction, a 2 as well. So this is our official answer right here for part B. It might be good to recap really quickly, right? We went ahead and did the complex conjugate. That's how these are pretty mechanical problems. They follow the same algorithm, the same process, the same pattern. We multiply by the complex conjugate of the denominator, and then we distribute the top, or FOIL it, or whatever we have to do. Then we do our little trick on the bottom. It saves us quite a bit of time. And then if there's any I squares, which there probably will be, we'll take care of those as negative 1s. And then we split it up into 2 fractions. And then if we can reduce, let's go ahead and do so. Part C is fascinating because we have a numerator and a denominator, full complex number. but we're going to only multiply by the conjugate of the denominator. So it doesn't matter what the conjugate of this numerator is. We multiply by the conjugate of the denominator. Okay. Now, I'm going to kind of work this a little bit different than the last ones because usually I go for the top, but this on the top is complicated. So I'm going to do the bottom first. What is 1 squared? 1 times 1 is 1. And then this 2 right here, 2 times 2 is 4. So my denominator is 5. But if we go ahead and are trying to do something with this, we can't do the fancy trick we just did. Those are not complex conjugates. We must work out that problem. So we either FOIL it, distribute it, box it, whatever you want. Okay. I'm going to go ahead and let's do it the old-fashioned way with foiling, right? Distributing. So that's a 1. That's a plus 2i. That's a plus 2i. And that's a plus 4i squared. Nothing canceled out because these are not conjugates. So if I go ahead and combine this plus 2i with this plus 2i, that's plus 4i. We recognize that true to form, there's an I squared. I squared is a negative 1. This is just, by the way, the numerator. We're not even doing the problem yet officially. We're just doing the numerator right now. And then this is a 1 plus 4i minus 4. And what is 1 minus 4? Well, if I owe you $4, but I paid you $1 back, I still owe you $3. So this, folks, is the numerator after all that mess. Let's split it up. Minus 3 over 5. 4 over 5 times I. Nothing to reduce. So that is the final form of part C. You know, a lot of you just write what I have on the board if you even watch the videos, or if you even take notes. I would beg of you, if you're watching this but not taking notes, you should be taking notes. And if you are taking notes, would you pause the video and retry part C on your own to see if you've got the algebra skills? And if not, you keep trying this problem until you get it. Okay? For part D, I'm going to kind of just have you fill in the blanks. So I'm going to go ahead and show you some of the steps along the way, but I'm not going to do it all for you. So at some point after multiplying by the conjugate of the denominator to both the numerator and the denominator, you're going to get to this step right here. I've eaten up like 3 steps to get to this point, but hopefully you can get to this point. And then after cleaning that up some, you're going to get to the final answer, which is going to be this right here. Kind of an ugly answer, but this part D follows pretty much the same pattern that we've been seeing with the other problems, in particular part C. So if you really spend time understanding part C, then you got part D. Okay? Feel free to hit me up on Remind or email me if you struggle with part D. E is so simple that it's hard. So we multiply by the complex conjugate, but what is the complex conjugate of 3i? Well, you might want to look back at problem 1 in the previous video. But it's going to be the opposite sign, so we're going to multiply by negative 3i. That's interesting. Well, we still can use my little rule here. 3 times 3 is 9. Done. Okay. The top we're going to distribute. So that's 2 times minus 3i is minus 6i. And then minus I times minus 3i is a plus 3i squared. We then go ahead and we have an I squared, so we recognize it as a minus 1. That's a negative 3. We can separate that. And we can reduce it because 3 and 9, they have we can divide them both by 3. So that's minus 1 over 3. And then these can also be divided both by 3. The 2 thirds. And yeah, this is part E. So it looked actually easier, but it was a little bit of work, I'm not gonna lie. Okay, so it's time to kind of reflect. What are some of the algebra skills necessary for the above problems? Now, these are skills that we have been reviewing quite a bit with previous topics, including matrices and functions. So you might want to brush up on some of the skills we've been reviewing because we're using them still.